morning. The last lecture we have discussed about the correct steering gear mechanism necessary equation, and we have seen Davis steering gear mechanism, and we solved two problems on Davis steering gear mechanism. Today's lecture will discuss about Ackerman steering gear mechanism and the necessary derivation, and we'll compare with Davis steering gear mechanism with Ackerman steering gear mechanism. Okay, so first let us see the last lecture, last discussion, what we did and what was the drawback with Davis steering gear mechanism. So the first drawback in the Davis steering gear mechanism is it consists of sliding pairs. When there are more sliding pairs, then there will be more wear and tear. So that was the thing which we discussed very beginning, okay? But at the same time, we said there is one advantage with Davis steering gear. The advantage is for any orientation, it fulfills the correct steering gear mechanism equation which we derived, that is cot phi minus cot theta is W by L equation. So that is the only benefit that you get in Davis steering gear mechanism. Okay, so to overcome the difficulties in the Davis steering gear mechanism, we can move to the Ackerman steering gear mechanism. So in the Davis steering gear mechanism or Ackerman steering gear mechanism, whatever it may be, it has to fulfill the fundamental equation, that is correct steering is cot phi minus cot theta is equal to W by L. So what is phi and what is theta, what is W and what is L? So the angles made by the inner wheel and outer wheel of the front wheels are called theta and phi. So you can see in this diagram for correct steering gear, we have written for a right turn, this is the inner front wheel and this is the outer front wheel. The angle made by the inner front wheel is theta and outer front wheel is phi, and theta is greater than phi, and where W and L is the distance between the two pivots of the front wheels, and L is the distance between the front axle to rear axle. So we have proved this, that is cot phi minus cot theta is W by L. If you have a correct steering mechanism, means that has to be fulfilled this equation cot phi minus cot theta is W by L. In case of Davis steering gear, for any orientation of these wheels, this is going to be fulfilled correctly. Whereas in case of Ackerman steering gear, this will be fulfilled only at three positions, that is extreme positions of left and right and at the middle position. Okay, that is also we have discussed in the last lecture. Okay, and that is stated here. The fundamental equation of the gearing is fulfilled in the middle and two extreme positions only. But only one advantage of Ackerman steering gear that prefers to use most widely, that is it consists of turning pairs. It consists of turning pairs. So as you are aware of a simple mechanics involved in the wear and tear, that is surface rubbing or surface wear is more, that is when you compare with the wear and tear due to the line or a point wear. So in case of Davis steering gear, the relative motion are all are sliding pairs where there will be more wear and tear. And whereas in case of this Ackerman steering gear, where the pairs are kinematic pairs are turning pairs, less wear and because of this, in a long run also, this Ackerman steering gear will work in a better way. That is the only advantage and that is the main attraction of Ackerman steering gear, where it is widely used in nowadays in your automobile systems, isn't it? So this is the animation which you are looking is an Ackerman steering gear. Okay, so here you can observe all are turning pairs. So the same mechanism, and we analyzed and we have written the necessary equations with this analysis. So you can see this is a simple diagram which is showing where the vehicle is taking a straight path. So this is the front axle, okay, left and right, and this is the rear axle. As we have already stated, steering is given to only front wheels, and where the rear wheels will simply follow the front wheels direction. Okay, so you can see here, this is one turning pair at A, and at M another turning pair, at N there is another turning pair, at C another turning pair. So all are turning pairs, A, M, N, C positions, all are turning pairs are shown here. So you can look at here, when the vehicle is taking a turn, that is shown here, it is taking a turn like this way. So when the vehicle is moving like this, as I say like this, it is taking a turn. That means which turn I am taking? So the outer wheel is moving that way and the inner wheel is going like this. So I am taking a right turn. I am taking a right turn, isn't it? So the inner wheel of this front wheel making an angle theta, and outer wheel of this is making an angle phi, isn't it? So as per our discussion in the earlier, when the vehicle is taking a turn, okay, then all the four wheels should rotate with a common instantaneous center. Then there will not be any skidding, otherwise there will be skidding takes place. So in case of this Ackerman steering gear, as I said, a correct steering is achieved only three positions, that is at one middle position and two extreme positions, isn't it? So the analysis gives you, for a correct Ackerman steering gear to achieve this, what is the alpha required with respect to theta and phi. So what is the necessary alpha? What is the necessary alpha required with respect to theta and phi? So what is alpha, what is theta and what is phi? How we can get this solution to get in terms of this final equation? First you should be thorough about the simple first year engineering graphics where we study the projections of a line, okay, and its path identification that should be strong, then only you can get this solution. Okay, so I will try my level best to incorporate those details with your projections of lines and those projections into the consideration in this analysis. Let us see, this is the straight path when the vehicle is taking on a straight road. Okay, this is the front axle, left and right axles, okay, and they are making an angle with this axle with alpha, okay. So my objective is to find out correct steering mechanism. So what should be the angle theta and phi in terms of alpha? So a relation to be developed in between alpha and theta and phi. So that let us see here in the analysis. So now you can see here, as per the definition or as per our notation, we are defining the inner wheel making an angle is called theta and outer wheel making an angle is called phi. And originally this is making an angle, so this Q and P is making an angle alpha with the vertical. So you can look at here the link QB and PA, link QB and PA is originally indicated by dotted line. You can see this is PA, this is PA, and QB is original, which is shown with a red line. So that is making an angle alpha initially. So when the vehicle is taking a turn, then the link QB is occupying a new position QB dash and PA is shifting to PA dash. So the new position which you can see, that is QB is shifted to B dash and PA is at PA dash, isn't it? So now look at what is happening. Now this is at QB and this is at PA dash. So I have shown a blue color for the movement of B to B dash and A to A dash, isn't it? So in this process, the wheel, inner wheel D and the outer wheel C corresponding to the front wheels are taking a position to D dash and C dash, isn't it? Now the inner wheel makes an angle theta and outer wheel makes an angle phi. So you can look at this, this is the theta and this is the phi. So theta and phi. So this is the theta, and this is the phi. Theta and phi. Okay. So once again you can see enlarged one, here it is shown very clearly. The same thing, this portion I have enlarged and I have shown here. So QB is making an angle alpha and PA is making an alpha with vertical. Now what is the next one? The QB position is shifted to QB dash and PA is shifted to PA dash. Okay, then the movement of this QB to QB dash is called theta and PA to PA dash is given as a phi. So you can clearly observe this theta and you can observe this is phi, isn't it? So then now let us take the projections of the BB dash on PQ and the projections of AA dash on PQ. So whatever this moves, the same movement it will be taken care by this. Then the projection of BB dash on PQ should be equal to the projection of AA dash on PQ. That means this distance is equal to this distance, because the B moved to B dash, then A moved to A dash. So the projection of this so the projection of this and that are equal. So that we will write here, from the simple geometry or simple your trigonometry, how we can write like, so projection of BB dash on PQ and projection of AA dash on PQ. How we can write, you can see, you can observe this is a triangle, that is QB dash is a triangle, and similar here you can observe there is a triangle corresponding to this PA triangle. So QB is equal to QB dash and PA is equal to PA dash, and at the same time PA is equal to QB, because here we have taken the links such a way that PA is equal to QB. This QB dotted 1 is equal to dotted PA. So the position of QB changes to new position QB dash will not change the length. Similar PA, even if it is changed to PA dash, length will not change. So the projections how we can get, let us see here, if this is alpha and this is theta, then the total angle is, this is alpha plus theta. This total angle is alpha plus theta. Similar here, this total angle here, this angle, is, as the total angle is phi and this angle is alpha, then the net angle is phi minus alpha. Whereas here it is alpha plus theta and here it is phi minus alpha. Look at the BB projection on PQ. So how I can get this value? Suppose if I know this and if I know this, so if I subtract from this and this, then I get this net value. Simply if I get this length and if I get this length by analysis, then I can get this value by subtracting this. The same thing what we did here, let us see. So you can see this is the triangle QB, okay, and this is one triangle and another triangle is this. These two triangles are taken into the consideration. So one is this triangle, that is which is this triangle where QB dash and this angle total is alpha plus theta. And what about the other one? So the other one is so these two triangles, look at this QB dash triangle and another one is QB triangle. So the projection of this, okay, this is the length. Say if I call this is some m and this is say n. So b dash m minus bn, b dash m minus bn, that gives my value of this part, that is projection of BB dash on PQ. So how I can get this? As I said, QB dash is equal to QB. So I can replace QB and QB dash as a similar term. So this is this length is QB dash sine alpha plus theta. QB dash sine alpha plus theta. As I said, QB dash is equal to QB. Then it can be written as QB sine alpha plus theta. Then this part is QB sine alpha. I did simply very simple basic fundamental equation by treating two triangles. This is QB dash, okay, M and QB N. QB dash M triangle and QB N triangle. So QB sine alpha plus theta minus sine alpha. In a similar way, whatever I have explained here, with that fundamental knowledge you can apply here. These triangles, that is PA sine alpha. So you can see this is one triangle. This is P A sine alpha. So this is the triangle. This is the PA sine alpha. I am adding these two. That means this and this. The addition which I am getting this yellow portion. How I get? This is already obtained PA sine alpha. Then what is this angle? Sine phi minus alpha. So PA and PA dash are same. That is, this is P and here this is A dash and this angle is phi minus alpha. Okay, then this part, the projection is PA dash sine phi minus alpha, where PA is equal to PA dash. Like QB is equal to QB dash, PA is equal to PA dash. Then PA sine phi minus alpha. That means I have added these two and here I have subtracted. So from this color to this color. I used here both the same colors and I used different colors because here I am subtracting and here I am adding to get it. Then as basically the PA QB values are same, then simply we can strike PA and QB. Then what is left? Sine alpha plus theta minus sine alpha is equal to sine alpha plus sine phi minus alpha. Then just simply expand by trigonometry, sine A plus B and sine A minus B. So this is sine alpha cos theta, okay, then sine A plus B, that is sine alpha cos theta and cos alpha sine theta. Then sine alpha term as it is expanded, the right side sine alpha, then sine A minus B, sine phi cos alpha minus cos phi sine alpha. Then simply rearrange the terms, alpha terms, sine terms one side and cos terms other side. So I can rearrange sine alpha into cos theta and taking from this side, then minus sign will become plus, then plus cos phi, and here minus sine alpha and here plus sine alpha. This, if I take this side, minus 2 sine alpha, then sine alpha is outside, it is there, then it is minus 2, which gives rearranging the words of cos on the other side. This is already cos alpha sine phi, and here you have plus cos alpha sine phi, then minus cos alpha sine phi. Simply rearranging alpha terms one side and phi theta terms other side, then it gives sine alpha by cos alpha is equal to sine phi minus sine theta by cos theta plus cos phi minus 2. So we know from the basic trigonometry, sin alpha by cos alpha is equal to tan alpha. So tan alpha is equal to sin phi minus sin theta by cos theta plus cos phi minus 2. And what is this theta and phi? Theta and phi are the values of the angles for the correct steering gear. Okay, so you can get the values of theta and phi for the correct steering in terms of alpha, isn't it? So this is the necessary equation required in an Ackerman steering gear. What is the alpha value we have to set for correct steering in terms of theta and phi, isn't it? So this analysis needs this diagram perfection. This diagram is also not a complex one. At first time when you look at it, seems to be a complex. Once you apply your projections basic principle, very simple, forget about all these things. Let us take how the case can be done very simple way. I will show you in a very simple manner. Very simple manner, you take a mechanism, okay, you take a mechanism, so you can take one mechanism with initially like this, which is making an angle of alpha. That is the basic mechanism. Okay, then you shift it to a new position. Okay, so you can take either right turn or left turn. In this case, we have taken actually the B is shifted to upward and A is shifted to outward. So the turn is taken like this inside turn, that is the right turn is taken. When you take a right turn, it goes to the other position, this and this. Then you can see this. The shifting is taken place from B to B dash and A to E dash. And this angle we can represent theta and phi. Then this net angle will become phi minus alpha, and this net angle will become theta plus alpha. Later part you project it, and with your simple geometry you can represent. This is these two parts and these two parts. Okay, so here we added and here we subtracted. This is added and this is subtracted. This is added and here subtracted. Addition, subtraction. Finally, you get this. Okay. So this is Ackerman steering gear and the necessary alpha angle. Then if you compare Ackerman's and Davis steering gear, of course all these points already we have discussed, and I have made a summary here. What is the difference of these two steering gear mechanisms? Look at in the Davis steering gear, the entire mechanism is kept on the front wheels, in front of the wheels, not front wheels, in front. That is the before the front wheels, the total mechanism is there. And what about the Ackerman's, the back of the front wheels? Back side, you have seen the mechanism on the Ackerman steering gear on the back side. And whereas in the Davis steering gear, you have seen the mechanism is on the front. This is Davis and this is Ackerman's. That is the first point saying. Then coming to the second point, the Davis steering gear will have all sliding pairs and Ackerman steering gear having turning pairs. So at the same time as Davis steering gear all sliding pairs, which will have more wear and tear. If there is more wear and tear, in the long run, the accuracy will be lost. And what about this other mechanism, that is Ackerman, less wear because of the turning pairs, and it maintains its steering for a longer period with less losing of its accuracy. And finally, in Davis steering gear, the law will be fulfilled in all positions. But what about Ackerman's? It will give only steering at 3 positions, correct one. That is 2 extreme positions and 1 middle position, isn't it? Even though the Ackerman steering gear will produce or provide 3 locations only correct steering, we prefer that because of its accuracy and long running and less wear and tear. And nowadays all your vehicles will have Ackerman steering gear, not Davis steering gear, isn't it? So with that we conclude the steering gear mechanisms. So the problems, even if it is asked in the Ackerman steering gear, it is only in terms of the relation which we obtained alpha, theta, phi by giving the values, the basic equation. If you substitute it, like some of the data will be given and you will be asked, or sometimes you will be asked by drawing the diagram for the given angles to find out the W and L other values. So that geometrical procedure or analytical procedure like this. Okay, with this we conclude the steering gear mechanisms. Thank you.